For roughly 20 years, applying composites in consumer manufacturing meant one specific thing to most design teams: a visible carbon weave applied to an exterior panel as a clear signal of performance. We can see the modern equivalent of this surface-level design right here on the Hyundai Ioniq 9. They've added a specific monochrome direction called the calligraphy black ink theme to act as their top-of-range signal. A named finish like this is a highly visible choice, and it's inexpensive to execute at the very end of a production line, but it remains entirely superficial. Right now, the most consequential composite work happening in the industry is occurring in structural parts that nobody will ever photograph. Designers who spend their time agonizing over the look of the visible bodywork are missing the foundational engineering choices that actually dictate the final form. Styling a surface offers an illusion of control. The actual power to shape a product lies entirely in the early, hidden architectural decisions that lock in a physical reality long before the styling phase begins. To see how those architectural choices work, we have to look further upstream. Hattie is currently printing military drone boat hulls at large format, effectively escaping the strict limitations of traditional boat design. Look at this standard wireframe. Because physical molds are incredibly expensive, manufacturers repeat one single cross-section down the vessel's length. 3D printing removes the mold entirely. The cross-section changes continuously along the boat, creating a genuinely different shape, not just restyled geometry. We can track this idea even further upstream to the concept of load transfer. Pictured here is the European Space Agency's Themis reusable rocket on the launch pad, supported by Canova's structural landing legs. Those legs aren't made of pure composite. They are a carefully engineered hybrid, and the critical design content sits entirely in the unseen collar, where a carbon-wound tube hands its massive load over to a machined metal fitting. That single structural joint successfully carried the full weight of the rocket rehearsal while delivering a 25 to 30% mass saving compared to an all-metal design. Removing a mold or engineering a hybrid joint are pure architectural decisions, and those architectural decisions are what actually move a product silhouette. We can push this timeline to its absolute origin, moving into an environment completely removed from exterior aesthetics. Inside Terra Supreme's Group 31 bipolar lead-acid batteries, the internal architecture relies on AGY S2 glass fiber for reinforcement. This microscopic composite material exists strictly to provide dimensional stability deep inside the cell. It is the furthest possible application from a styling material. Yet this internal stability scales up rapidly. It dictates the foundational mass and volume requirements of an entire electric vehicle long before anyone attempts to draw a sketch. The absolute physical boundaries of an EV's final shape are permanently locked in by these dark, hidden battery structures. Form always follows invisible engineering. We continuously examine this dynamic at Depix. Our future generation private jet concept acts as the ultimate realization of material serving entirely as structure. In this top-down schematic, the aircraft's architecture is a single continuous printed structure. The fuselage and the wing are completely unified beneath a smooth, translucent membrane. The core innovation is how the structural lattice density varies dynamically based on the exact load it carries. It is tightly packed and dense at the wing root, and then opens up significantly toward the wingtip. By designing this way, you eliminate rivet lines, lap joints, and separate frames entirely. The surface simply changes its density rather than requiring a change in physical parts. This creates a direct through line connecting the jet, the battery, the rocket, and the drone boat. They all represent the exact same core dichotomy, choosing whether a material is going to be used as a finish or as a structure. A finish can be decided late in the production timeline and changed cheaply. A structural choice permanently dictates part count, joint strategy, and the massive cost of tooling. These heavy architectural choices must be settled completely while the product's design window is still open. Design decisions are incredibly cheap when they are just a sketch on a screen, but they become brutal the exact moment they are sent to tooling. You have to see every structural angle before you build, and that is exactly what we help you do at Depix.